Okay, so let me. This will take around 30 to 40 minutes, and the breakdown is around. Let's say we start with the history of STOPAQ, the technology, what the invention is, the applications, and then we go through some of the photos and a few videos on a wide variety of applications that we have done in the past 30 years. So I'm based in Singapore. I used to be working for STOPAQ in Europe for about 8 years, and since 2 years I'm based in Singapore to look after the Southeast Asia region. These are the countries which therefore also includes Philippines, of course, and we represent STOPAQ as a master distributor for the Southeast Asia region. STOPAQ itself is part of a bigger company from the US, which is called Seal for Life Industries. This company is fully focused on corrosion protection. They have different types of technologies. They have, for example, Polyisobutene, which are 2-ply, 3-ply tapes. They have covalence, which is the former Raychem heat shrink sleeves. They have anode flex, which is cathodic protection, linear cathodic protection, and Powercrete, which are liquid epoxies. And STOPAQ is part of that. And now with the new acquisition, I know that you guys are representing Oxy-Free too. Oxy-Free was purchased beginning of this year. But these 5 are the original companies, let's say, under the umbrella of Seal for Life.
By the way, can we ask questions during your presentation, or we will do this at the end of the presentation?
No, absolutely. You can ask whenever you want. That goes for everyone.
Okay. So with regards with all the concerns, actually I've been I don't know if you still remember me. I've been with a meeting before in some of the event in the States, in Texas, with STOPAQ group of companies, maybe about 4 or 5 years ago. I don't remember. That's quite long. And then a lot from Thailand, from Malaysia, from Europe came over here. We did some training here in the Philippines for the STOPAQ and corrosion protection. That's why later maybe we can expand more training aside from STOPAQ. Are you the one handling everything?
No, we are fully focused on STOPAQ.
Okay, got it. Okay.
Yeah, and that's also the strategy of Seal for Life. They want to have dedicated companies representing each of the technologies.
Okay.
Because it's very difficult. Because every technology that you just saw, whether that's STOPAQ or whether that's Polyisobutene or covalence or Powercrete, each has its specific technology invention, therefore also requires a specific knowledge and experience. So it's very difficult for one company to do all, because that means you need to have a lot of technicians fully qualified and with a good track record, which of course is possible, but yeah, we can discuss that later.
Got it. Thank you so much.
Okay, so this is the what you see now is actually the head office of STOPAQ alone. So this is where the products of STOPAQ are manufactured. This is in the north of Holland, in the Netherlands. You see the offices, the warehousing, and the production facility, and also you see the sand and the side beams. They have a little offshore platform for rope access. It's like an outdoor technology park, testing field that we use, besides the indoor laboratory. So this is where, in the 1980s, the product STOPAQ was invented. And STOPAQ stands for Stop Aqua. Why? Because Holland, the country where also I am from and where the technology is from, is actually below sea level. 60% of the country is below sea level, which means we have a lot of water ingress and water problems. So we have to learn, or we have learned to live with a high water table and to make sure that our buildings are sealed off. This is one of the things that Holland is famous for, all the dikes and the waterworks that we have. And STOPAQ in the 80s and 90s was actually a sealing, a waterproofing company. And we started with cable duct sealing, which, for example, we do for telecom cables running through buildings. I'll show you a little video. This was the first product of STOPAQ. There's a water column on the other side, so there is water pressure. He's just scraping it out right now. And they inject the STOPAQ, which is here in a cartridge. It swells and it stops the water from flowing through. The material itself and also the corrosion materials, they don't cure, which means that there will always be a flexibility, like for example, a chewing gum. So this is how it started in the 80s and 90s. And in the 90s, we were asked to seal compressor stations for the gas company in the northern part of Europe because they had a lot of water ingress. And then there's a joint venture in Holland from Shell and ExxonMobil. And these engineers came and took a look and they said, hey, this material is actually also applicable as a corrosion prevention material. Why don't you make it in a band form, like a tape, and we wrap it around our pipes? So that was something new for us, and we started doing that. And now actually, instead of sealing, our business is 90% consisting out of corrosion. External corrosion, I have to say. We don't do internal corrosion. We only do external corrosion. So STOPAQ is a combination, or at least the STOPAQ technology is based on a polymer from a German company called BASF. The polymer is called polyisobutene, and yeah, it seals against corrosion and any water ingress, and that goes for anything from onshore, offshore pipelines, refineries, petrochemical, anything that is steel that corrodes, we can treat. These are the products. This is a product overview that if you get the products in your warehouse or in a box or pallet, you see this is the way they look. So you have the sausages, and then you have the cartridges, and then you have the rolls, which are able to wrap around pipes, which also this application that we're going to talk about later is applicable. The material is used for external corrosion, and mostly what we do is maintenance work, preventing these type of issues that they have, corrosion issues. And what do? We are a corrosion company, corrosion protection. So on the left side, you have unprotected steel. And then on the right side, you see it's protected by coating. So what is it called? We are called a barrier coating. We protect the substrate. We separate that from the environment, meaning it cannot react with anything that might be corrosive or start the corrosion process. This is the polymer, polyisobutene. Was already invented in 1935, so a long track record. In the 90s, we were the first one to to get the flow under control, and we have patented the corrosion application. So from BASF, we are the only ones that can use it for corrosion. It's impermeable for water, water vapor, and gas, high electrical resistance, which are all good qualities for a coating. Other than that, you can compare it to a chewing gum because it sticks to all sorts of surfaces with a minimal substrate preparation. So it sticks to polyethylene, polypropylene, fusion bonded, but also neoprene, thermal sprayed aluminium, thermal sprayed zinc, copper, aluminium itself. And one of the advantages of the STOPAQ system is that it is self-healing. So the material always comes in two layers. You have the green inner layer directly to the substrate, which is the green layer you see on the outsides actually. And then there is an outer layer, which could be a outer wrap, just a normal tape. Apologies. And this is what we call a coating system. So it comes in two layers, the wrapping band, the outer wrap. And we make a hole in this system, and given time and temperature, the material will self-heal itself. This, of course, only goes for small punctures. This is not for diameters of like 20, 30 centimeters. That will not be applicable. As I said, it's a two-layer coating system. It has separated functions. So the first layer is the corrosion prevention layer. That's the green one on the left. Then the second layer can be a choice. It all depends on the environment conditions. In this case, usually you can use a outer wrap, but in high impact or in soils which are maybe contaminated with hydrocarbons, you can use a glass reinforced epoxy on top. One of the advantages of STOPAQ, it requires minimal surface preparation. It doesn't need blasting. It will do with ST3 prepared surface. It's fast and easy to apply. There's no curing time. There's no shelf life, pot life, and it is inert to aging. So it doesn't age. Whether you use it now or in 20 or 30 or 50 years, the material stays the same because it's not like an epoxy where you have component A and B. No, this is just one component and it doesn't age. So to say, compared to conventional coatings, it's not dependent on temperature during application, the temperature, relative humidity. There's no need for a Bresel test, and there's no need for an anchor profile. Power tool cleaning is necessary, solvent cleaning, and then you do the application manually. Before you do or after you do the surface preparation and before you start applying, you do a little cleanliness check to make sure that the surface is clean enough. You stick the STOPAQ, a small piece of STOPAQ onto the surface, and you remove it. If it sticks to the surface, this is perfect. Then that means you can start the application. If you see this, it's dirty and you need to do more cleaning. Power tool cleaning and the solvent cleaning. So this is what you will see if you try to remove the layer from the substrate. There will always be a sticky layer onto the steel. This will protect the steel surface from corroding. The outer layer, like I said, it depends on the soil and environmental conditions. Here you see we do a soil stress test, different types of materials as an outer layer, heat shrink sleeve, tape, outer glass shield, polyester, and we try to make the best combinations possible for the longest durability of the total coating system. Soil stress analysis is of course the pipe, for example, if it's underground, the ground is still moving. Therefore, the pipe is moving, therefore the coating will endure certain stresses. Going from here, what we do is, for example, we write inspection test plans, quality plans, we have application manuals, PQTs, PPTs, depending on the project, depending how big the projects are, and depending on what the requirements from the client are. So now we go through some of the pictures. It's easy for you to see what is the material used for. One of the things what is very unique for a coating is to be able to stick to neoprene. For STOPAQ we can. This is a connection hose offshore that we seal the connection points. Flange protection, you seal the gasket in between the two flange faces. Structural steel, we apply the green layer on the structural part and we top coat it. So this is no outer wrap. This is where you use a paint on top of the material. This is the finished product. Underground storage tanks, applied with the green layer first and then a black outer layer. And we do field joint coating. We do maintenance on, for example, above ground structures of a plant. So you see on the left the green layer, and this particular client wanted to have a white colored outer wrap. We do pre-insulated pipes, which you either do over insulation or under insulation. Corrosion under insulation, that is called COI. Here you see over insulation. This is actually in the Philippines, Phoenix Petroleum. Underground valve protection. There's a lot of irregular surfaces, so the STOPAQ material is very flexible and easy to mold around all these irregular parts, and you can fully wrap it where you see it here. The green is already underneath. This is the black outer layer. Tank chime, which is this is a big storage tank. So what we do, we seal the bottom plate that there can be no ingress of water underneath. Risers, soil to air transition area. Then the riser, you go from below ground to above ground. Normal straight pipeline rehabilitation. You see here long stretches, 26 kilometers. This one is in the Middle East. Saudi Aramco does the same thing. It's one of the contractors you see here. Sweating pipes. There's a lot of condensating pipes, especially if the medium through the pipe is cold, like gas, for example, and you have a humid or a warm environment here. The pipe starts sweating. You can coat it using a shutdown of the whole plant, but for our material, it's not needed. We can apply it onto a wet surface. This is a different material. You see the light green and the dark green. This is the dark green material that can be applied on a wet surface. It's also a two-layer system. This is in Chicago. It's in the US. There's also a sweating pipeline. There's a tunnel part. We use it also for subsea coating and jetty piles like this. You see here in Brunei. They also use it for a jacket lag. There's an offshore platform in Australia where they do by rope access. They apply it. These are conductors on a platform in the North Sea. They apply the two-layer system. Some specials that you see here. This is the actually a video that just came by. Is similar to this. It's offshore field joint coating. It's on board of a ship, so they do pipe lay, and they coat the area. I'll have a video here. So they do surface preparation. Solvent cleaning. And then this is the first layer. The green materials are the first layer. So the cutback here is quite big, so they need 4 strips of the first layer to be applied. So after this first layer, you do the holiday test to make sure that there's no holes. Then they apply the second layer, which is the outer wrap. And then usually this is already the total system, but for offshore, they use a extra layer, which is this one. This is the rock shield. This is rarely used onshore. This is just to fill up the void between the coating and the gray cement layer, or concrete layer, sorry. Some of the offshore projects in the last 2 years that we've done here in Malaysia. Stainless steel applications that we are going into, especially for Woodside in Australia. Some more applications here, some T-joints, some flanges, and just straight pipes. We also have a mobile coating plant for line coating here in Singapore and in Malaysia. So what we do is we coat pipes on site. So actually it's more like a pipe mill. This is one of the projects we've done recently in Malaysia for an upgrade on a refinery. They wanted to have more pipes ranging from 2-inch to 30-inch. And we coat them on site with a 2-layer system. We ship it to site, they weld it together, we do the field joint, and they start the operations. This is what it looks like. So you see here, the black outer layer is just a normal polyethylene outer wrap. And this light green is the glass reinforced epoxy. Well, the technology itself has been around for around 25 to 30 years. It's been tested a lot, especially in Europe, some other places around the world, in China, for example, but also in the US. This is the green material after a 40 years aging test. One of the certifications that we have is, for example, the ISO standard. We have a lot of joint research with Shell, and then we have the other ones are Kiwa, which is a European water agency, DVGW, the CO as well, and COT is just testing reports. So this was actually, in brief, the presentation on the technology. Does anyone have any questions?